Today we're going to be talking about polynomial inequalities and rational inequalities. Polynomials, specifically today, quadratics. And I'm going to go ahead and show you this first one. This is just going to be a quadratic equation. Remember a quadratic equation? The graph ends up being, that's not a very good parabola, not very smooth, but a parabola. If there's a negative sign in front of the x squared, it's an upside down parabola. And then later on when we learn conics, they can be sideways. But for right now, when they're inequalities, there's still shading involved. Most classes teach you that when you have an inequality like that, you're still going to solve. So y is greater than or equal. In this case, you'd have to use the quadratic, and when you get it finally solved, you'll figure out what the x values are. When you figure out the x values, and these will be square root, because there's an equal sign right there, underneath the inequality, you can put solid dots. Well, notice what happens. It creates these three intervals out to the left of the parabola shape, in between the parabola shape, inside the parabola shape, and to the right of the parabola shape. Typically, what professors want you doing is pick a value from each. So in this I might choose -6, or maybe I'd choose -10. Anywhere in this interval. Inside this interval, I'm probably going to pick -3 because I know that that's the vertex value. And over here, anything to the right, I'd probably make it easy and I'd pick 0. You plug each of those values in, so it'd be -6 squared plus 6 times -6 plus 6. And then you figure out, is that a positive value or negative value? Then right here, you plug in -3, you plug in all of those things, figure out, is it positive or negative, and you mark that. Same with over here. Here's the deal. We'll practice that in class, but what I'm going to show you is a really quick way to notice. Notice this right here says y is greater than or equal. I'm going to look right here at the vertex point. Notice here are the y values. The y values go up or go down, but this says y is greater than or equal. So what I want you to do is, where are the y's bigger from right here? Well, the y's get bigger up here, so you're going to shade everywhere on the inside. All right, we're going to go over to this next one right here, and notice this is not, this is just greater than, not greater than or equal to, so you'll have hollow dots. The other thing that I want you to notice is there's a negative sign before the x squared, so we know it's going to be turned downwards. This still says y is greater than. The other thing that I want you to notice is all of these share a factor of 2. So we're going to divide, set y equal to 0, and then divide every term, divide it by 2. So we're going to divide all the parts by 2, and now you have 0 is greater than x squared, negative x squared minus 4x minus 2. So it kept its negative sign. We know that it's still turned upside down. And because of the numbers involved, you'd have to use the quadratic again, or plug that into Desmos to see the graph. Desmos is not going to show you the shading. But notice the inequality, sorry about that, that should not be there. The inequality is going to say y is greater than, there's going to be a negative sign. Notice, because there's not this solid line, even the parabola has dashed lines. You don't draw the graph with solid, and then where the roots are, you put a hollow dot. Where the vertex is, put a hollow dot. And then notice this time, y is greater than. We still are going to look at this vertex point. Well, the points are bigger above the vertex. So because the y's get bigger outside the graph, you shade everywhere outside the graph. All right, we're going to move on to absolute value. Whoops. Rational, and I'm moving too quickly. Here's a little bit of a different. Here you have an inequality, and this is a rational expression. So here is the ruling on this. I'm going to put a graph right there. You first have to get this side equal to 0. So you would have to subtract 3 from both sides. When we subtract 3 from this side, it's going to look like that. And then now we have is greater than 0. All right. Now, this -3 or 3 over 1, they need to have the same denominator. So like what we were doing last week when we have fractions with, here's a quantity, we have to multiply top and bottom by the quantity of 2x subtract 12, 2x subtract 12. When you do that, you end up with 5x plus 19, subtract, we're going to subtract all of this, 3 times 2x is 6x, there's a subtract sign, 3 times 12 is 36. Now they share the denominator of 2x subtract 12. We can simplify this now. This says subtract 6x. Well, here negative 5x subtract 6x is negative 11x. Well, now we have positive 19. Well, look at what we have. We have subtract negative 36. Subtract a negative is the same as adding a positive. And we have 2x subtract 12. And all of that is greater than 0. Now what you do is you're going to set the numerator, negative, I didn't need that parentheses, negative 11x plus 36 greater than 0. And you're going to set 2x. Oh, I'm sorry. 36 plus 19. I knew that didn't sound right. Sorry, here's my mistake. I told you subtract a negative is the same as adding. Well, 36 plus 19 is 55. There we go. That makes more sense. So this is 55 now. There we go. All right. And then 2x subtract 12 is greater than 0. You just have to solve for x. And if you think about it, 55 plus its opposite, so negative 11 times what is negative 55? Well, x would equal negative 5. And right here, 2x, oh, I'm sorry, positive 5, because this is negative 11, we need negative 55. 2 times what will equal positive 12, because this is subtract 12, well, 2 times 6. So we have x is equal to 6. So now you're going to have this interval. Instead of this being coordinate pairs, you now have this interval, positive 5 to positive 6. The numbers between the x values between positive 6, positive 5, and positive 6, everything in between here, this infinity between 5 and 6, and that should be hollow dot, sorry, because that's a greater than sign. These are the values. Anywhere in between here will make the inequalities true. All right. Yeah, this is kind of a lot more advanced. We'll be practicing this stuff together in class. All right.